So we are starting chapter 2, which is continuing with all these trig functions. Our focus is going to switch just a little bit. In the last chapter, I kind of talked to you a little bit about how to use a triangle and the SOHCAHTOA, but we were mostly just dealing with the X, Y, and R definitions because we had quadrantal angles, we had angles in different quadrants, and had to watch the positives and negatives. In this section, we are going to talk specifically about triangles and how those trig functions relate in those triangles. So the first, our SOHCAHTOA definition. I already kind of gave this to you, but let's refresh. This works in a right triangle, and only a right triangle. So what does this SO represent? What about the CA? Cosine is? And TOA means tangent is good. Now the key, it has to be a right triangle because only right triangles have a hypotenuse. Okay, if we don't have that 90-degree angle, we don't have a hypotenuse, and this definition doesn't work. It is also going to be extremely important. When you write a trig function, you have to tell me the angle you are viewing from. Okay, you can't just say tangent equals 5. I have to know tangent of what? It would be like having a square root with nothing underneath. That doesn't make any sense. So anytime you're dealing with a trig function, you have to tell me the angle. If I took this right triangle ABC, just some notation things, we use capital letters for the angles, lowercase letters for the sides. And our sides go across from the angles. So side A is across from angle A. Side B is across from angle B. Side C is across from angle C. In terms of opposite, adjacent, and hypotenuse, what is side C? That's the hypotenuse. Okay. But the opposite and adjacent are going to depend on which angle I'm viewing from. So that's why it's very, very important that when you write a trig function, you give me an angle. So I'm going to do the 6 trig functions for angle A. So if I'm viewing from angle A, which side is opposite? A. This would be my opposite side. And that means this has to be my adjacent. Adjacent is the side that touches it. What would happen if I picked angle B as my viewpoint? The opposite and adjacent sides flip. When we are using SOHCAHTOA, we have to do it from one of the 2 acute angles. We cannot do it from the right angle, because if C is the angle I'm looking at, what's true about my hypotenuse is also my opposite. And so then my definition isn't going to work. So this only works from the acute angles. So using this picture, sine of A. So sine is opposite over hypotenuse, so that would be A over C. And if we have sine, we automatically know cosecant because they are reciprocals. So cosine of A, cosine adjacent over hypotenuse, is B over C. So that means secant, the reciprocal, is C over B. And tangent, opposite over adjacent, so that would be A over B. So cotangent is B over A. Any questions there? Let's look at an example. So we're going to have a lot of problems like this where I'm just going to tell you in words, and we're going to have to draw a triangle that meet the requirements. Probably very common here, people will make mistakes by labeling the sides incorrectly. So just watch it when you are reading this. We have triangle ABC is a right triangle, and C is the right angle. Okay, so I'm just going to call my other angles A and B. Side A is 6. Where do I have to put the 6? Right on the bottom, opposite angle A. Side C is 10, so that would be my hypotenuse. Find the 6 trig functions of A. What do I need to do here? We have to find B. How can we get that? Pythagorean theorem. A squared plus B squared equals C squared. Just like x squared plus y squared equals r squared. Okay, so my A is 6. I don't know B. C is 10. The nice thing about this, if I'm not worried about this being in various quadrants, if I just have a triangle, what kind of measurement does everything have to be? Everything's positive. We don't have to worry about any negatives here because I'm not putting it in a certain quadrant. I'm drawing a triangle. So my side B is just a positive 8. I don't want decimals, so if it was something like 60 and you had to do the square root, just break it down as much as you can, but keep it in radical form. So I want the 6 trig functions of A. So this is my viewpoint. So think about our SOHCAHTOA. Sine is opposite over hypotenuse. So my opposite side is my 6. My hypotenuse is my 10. My 8 is my adjacent. So sine 6 over 10. Again, I don't want decimals, but we could write it as a fraction. That would be 3/5. And if we know sine, then we automatically know cosecant is the reciprocal, 5/5. Okay, cosine is adjacent over hypotenuse. So 8 over 10 is 4/5, so that means secant is 5/4. TOA, tangent opposite over adjacent, so 6 over 8 is 3/4. So cotangent is 4/5. Any questions there? Okay, so example 2. I want you guys to do this on your own. It's asking you to use that same triangle, but this time I want the 6 trig functions of angle B. So use the same picture. So all that changes. The hypotenuse is always the same. But if I'm at angle B, side B is now the opposite, and side A is now my adjacent. So sine, opposite over hypotenuse, becomes 8 over 10, or 4/5. That means my cosecant is 5/4. Cosine, adjacent over hypotenuse, 6 over 10 is 3/5, so secant is 5/5. Tangent, opposite over adjacent, is 4/3, so that means cotangent is 3/4. Now compare the two. So sine of A, what did that equal? Sine of A was equal to cosine of B. Cosine of A became sine of B. Tangent of A is cotangent of B. Cosecant of A, secant of B. secant of A, cosecant of B, and finally cotangent A became tangent of B. What kind of angles are A and B? They're two acute angles. How would they be related to one another? They are complements. They have to add up to 90. So what we just found is that if the angles are complementary, sine of one equals cosine of the other. Tangent of one equals cotangent of the other. Secant of one equals cosecant of the other. This has a name. These are called cofunctions. So cofunctions are equal when the angles are complementary. Okay, and the sets you can have sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. Okay, this is different from reciprocals. This tells us when the angles are the same. So cofunctions are equal when their angles are complementary. So let's see. I'm asking you to find theta. And I have secant of 5 theta plus 14 equals cosecant of 2 theta minus 8. How would you find theta? What kind of functions are secant and cosecant? They are cofunctions. When are cofunctions equal? When the angles are complementary. What does complementary mean? So these angles have to add to 9. So 7, 3. My theta is 12. Any questions there? All right, so then probably the last thing we'll get through today. I want to talk about some common angles that come up. Okay, we've already done a few of those. We've done 0, 90, 180, 270, 360, those quadrantal angles. There are 3 others that we are going to see a lot. So we need to talk about those 3. I gave you a triangle here with the sides measured. These aren't just random measurements. I mean, if you're interested in where it came from, I started with an equilateral triangle. What does equilateral mean?
All sides equal.
All sides are equal. So if I call them all 2. Okay, what would every angle be?
Same.
The same. So 180 divided by 3, each angle is 60. Okay, but we know our trig functions only work in what kind of triangle? A right triangle. So then what I did is I took it and dropped perpendicular. So then the bottom was half of 2, which is 1. The top angle became half of 60, which is 30. And I did Pythagorean theorem to get this height of radical 3. So I don't want you to think I just like randomly put angles and numbers on there. That's where it came from. But I want to use this. And I want 6 trig functions for 30 degrees. So So the sine of 30 degrees. Make sure you write 30 degrees. Don't just put sine equals. So from my 30-degree angle, my opposite side is 1. My hypotenuse is 2. So the sine of 30 is 1/2. That means the cosecant of 30 degrees would be equal to 2. Okay. Cosine of 30 degrees. Adjacent over hypotenuse. The hypotenuse is my 2, so that means the radical 3 is my adjacent. So then secant of 30 degrees, if I did my reciprocal, what do I have to do there? Can't leave a radical on the bottom, so multiply by radical 3 on top and bottom. We get 2 radical 3 over 3. Tangent of 30 degrees. So tangent opposite over adjacent, 1 over radical 3. Multiply the radical and you get radical 3 over 3. Then cotangent of 30 would just be a radical 3. And I could have very easily asked you to do all these for 60 degrees as well, right? So 30 and 60 are 2 of these angles that we need. The other special relationship or special angle is 45. So let's try that, the 6 trig functions for a 45-degree angle. So if I'm going to draw a triangle, if one angle is 45 degrees, what's the other? Let's call these, let's say if I made both of these side measures, they would have to be the same because those 45s are the same. So if those were both 1, what's our hypotenuse? So this missing side is the square root of 2. So we need to pick one of our 45-degree angles, doesn't matter which one we view from. So if I want the sine of 45. So opposite over hypotenuse, 1 over the square root of 2, which gives us square root of 2 over 2. Then what's the cosecant of 45 degrees? Just square root of 2 over 1 or square root of 2? Cosine of 45. So cosine adjacent over hypotenuse. So that's 1 over square root of 2 or square root of 2 over 2. Then secant would be square root of 2. Final one, tangent of 45. So opposite over adjacent, 1 over 1 is just 1. So cotangent is 1. All right. So here's the thing. We need to know these for the 30, 60, and 45. But I'm not just asking you to go home and memorize all these different values. I want to give you some tricks for helping to learn them. So the last thing I'm going to do today is I'm going to talk about one trick for learning these, and then we'll pick up with this section tomorrow. Okay? So what I like to do, the easiest option is the hand trick. So on my hand, my fingers are going to be these common angles. So my thumb is 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so those are all the angles we need to be able to give our trig functions for. When we do this, sine is going to be the square root of the top divided by 2. Cosine is square root of the bottom divided by 2. Tangent, I already told you once, it's sine over cosine. So square root of the top divided by square root of the bottom. I'm sorry, I should have given you a printout of a hand. That would have been nicer. Try to make a mental note of that. All right, so here's how it works. If I said I want the sine of 30 degrees, you fold in your 30-degree finger, so that's our index finger. Sine is the square root of the top over 2. So when I say top, I mean the fingers above the one we folded in. So how many fingers are above the one I folded in? 1. So I get the square root of 1 over 2, which is, what's the square root of 1? You get 1/2. Is that what we wrote down for the sine of 30? Yeah. So if I asked for cosine of 30, cosine is the bottom. So how many fingers are below the one I folded in? 3. So the cosine of 30 would be square root of 3 over 2. Tangent, I said, is square root of the top over square root of the bottom. So square root of 1 over square root of 3. Get your radical off the bottom and you get radical 3 over 3. Does that match all those values we wrote down? Okay, so if I said I want to know the sine of 90 degrees. So here's a little fun fact about me. I can't bend in my pinky finger, so I have to hold it down. So sine of 90 degrees. How many fingers do I have above the one that I'm holding down? 4. So square root of 4 divided by 2. 2 over 2 is 1. So the sine of 90 is 1. Cosine of 90. How many fingers are below the one I'm holding in? So square root of 0 divided by 2 is 0. Tangent, square root of the top over square root of the bottom. So square root of 4 over square root of 0, 9/5. So if I said tangent of 45, you fold in your 45. So it's square root of the top over square root of the bottom. So radical 2 over radical 2 is 1. If I said cosine of 60, you guys figure it out. What's the cosine of 60 degrees? Sine is the square root of 3 over 2. Cosine would be square root of 1 over 2. Sine is above, cosine is below. Does that make sense to everybody? Okay, if the hand trick doesn't click with you, please tell me sooner rather than later. Tomorrow I am going to go through, we have this table that we're going to fill out and we're going to use the hand trick to do it. So I will be practicing this with you guys a lot. But it is a great way to be able to figure these out. Are there any questions for me right now? So what I'm going to do, I'm going to go ahead and give you the homework. In case you want to get started, you've got a few minutes now. Tomorrow, we will finish the section and then have some time to work in class as well. This is the entire assignment for the section. So for today and tomorrow, so this will be due Wednesday.